40 tips or tricks that every developer should know. For once, no MVVM. Hello and welcome to my session, the 40 tips or tricks that every developer should know. As it says in the description, for once it's not about MVVM or other software patterns, but rather about little things that make the developer's life easier, make the source code more readable, or are just nice to use. The experienced developer might get bored with one or the other trick, but I deliberately designed my session this time so that beginners can also get something out of it.
For those who don't know me, my name is Frank Lauter. I'm an Embarcadero MVP and I have been programming in Pascal and Delphi for over 35 years. For more information, please visit my homepage, where you also can find information about my services like source code review and consulting. My favorite topic is the development of FireMonkey application, for which I also offer training in your office or remote. As well as my blog From Old School to New Frontier on Blogspot, and the German version of my blog, which can be found on the Embarcadero homepage. It deals mainly with my favorite topics, MVVM, FireMonkey, and my FireMonkey development kit, which offers many useful features also for VCL developer. In order to spread these topics even better, I've started this year by publishing video series on my YouTube channel, Delphi Profi. Of course, I'm happy about everyone who subscribes to my channel and links to it.
Okay, let's start with something very simple. Let's start with a new unit and save these. And there we create our beloved foo. As a record with name and value, and a function that returns a foo as a result. Maybe a constructor. Yes, that also exists for records. Then we can return this. Of course with 42. That's how I wanted it. On our main form, actually, I would do that with unit tests, but we'll save that at this point. So we just use a button with the text test only. Then we take a memo. So, for this example, we want to output the 42 to the memo when foo is test in it. So, for that, of course, we need to include the unit. That should actually work like this. Let's test that right away. Fine, it works. But what happened now? Let's have a look at this with the debugger. When we click on the button, of course the function is called, it creates a foo and for the value the same is called again, and of course we don't want that. So we have to optimize that. How about if we give the record another function first? Called has value and it returns a boolean. The same text has the effect that we can simplify the comparison. And now we can also lowercase the t. And of course it still works. That the duplicate call problem still exists. And so we take this. I call this the if-out pattern. We already know this from other functions in the runtime library. And the trick is very simple. The Haas value now gets an out parameter, and in case the comparison returns true, we pass the value out. Now we update the parameter. So CRTL Alt Shift P, and up there is also the out value. And then we can write the whole thing as follows. And make bar L value here. This way the function is called only once. And of course this still works. Let's quickly do the negative test. Works, too. By definition, in the false case, a value is not used and is therefore undefined. Of course you can define the else case for an integer and return -1 if necessary. But of course you can do that as you like. Let's move on to the next trick. We wanted to call this a trick, not a test. We are changing that right now. So how about we output both values to the memo? Memo 1. To string. Let's take this from above and add an integer. -1 is of course stupid. But you've seen it already. If I take the help here, I'll pull this down. There are other parameter overloads here. So if I specify true there, what happens? I'm also not so good, and I suppose you didn't expect it to be like this. Let's do the first test. Do we call our has value at all? No. Let's see with the debugger what is called in which order. I press F7, first the lines are fetched. OK. Then from the sysutils the bool to string is called. But not as we expected with our value and true as parameter. Therefore the bool strings are not used and our has value is not called at all. Now we can say we call bool to string with true. Now our function is also called and we have the result we expected. Who now gets the idea? Yes, you also use the new Delphi 11. This here is 10.4. Same, function not called. Delphi 10.3. Function is not called. Delphi 10.2. Function is not called. I'll do one more. Delphi 10.1. Function is not called. One reason why I like to use my own routines. I'll take my toString with another overload. The function is called and lo and behold, it works. Now we do the counter test. Attention, with false our value is undefined. Just as we expected. Of course, we can still change that as already discussed. And voila, using the right bool helper, it works as expected. Let's move on to trick 3. I have redesigned the form a bit, but let's see what happens first. Not set is false and set is true. What did I do? I have defined a null label. Here I use again the bool toString from the sysutils. We'll take a look at what the unit looks like right away. Why the bool toString? Of course, so you can follow this demo even without my FireMonkey development kit. Then I just set the value in at the same call, but we have already seen the result. Here we have our implementation. I have changed our foo record a little bit. String types are managing. This means that they are automatically initialized and deleted. That means, if the local variable is created here, the string is empty and I can simply test that here in the hasValue function. And depending on the assignment, result is set and the value is returned. If a value is set via the setter, then I simply assign the string with a character. After that, the string is no longer empty and true is returned. Now it would be nice if the whole thing could be solved generically. A small test for this as well. So now let's take a look at my implementation for this. No, value not set. And now comes the trick. I now assign the Boolean value false without having to specify value. Yes, and you can see that the value is set to false. If I now assign nil to the Boolean, no, so the value is now no longer set. Okay, trick 4. And again a 42. This time I created a myFoo class. The object is created and I check the bar value with the usual test. And we see there is a 42 stored. Of course, I didn't assign the 42 in the constructor, but this time I assigned the value via an attribute. For this purpose I have created my own attribute, for the myFoo record from trick 1. For this I only have to read out this attribute in the constructor via RTTI. Of course there is a helper in my FireMonkey development kit for this to do the whole thing in one liner. But we are running out of time, and this would go beyond the scope here. You have surely noticed, I have created a class here without releasing it. Of course, we would secure such a thing with a try finally. To release the object again. Or we change the implementation a little bit. For this we create a second class. In this implementation we use an interface. IMIFU. So we need to define the corresponding interface. Control-Shift-G generates the GID for us. And here we define a bar function that returns in foo. Procedures and functions that come from the interface are always written under strict private. The only reason for this is that I use this as a signal to mark these functions as interface functions. Then we create the object. Here we simply deliver var back again. The function just returns our tfoo. To simplify it we just copy and paste the stuff from above. On the tick 5 button, almost everything remains the same. Now the small proof that the distributor is also called. A reference counted object, everything works fine. Let's move on to trick 6. Trick 6, of course, also provides a 42. We would like, for a normal class, perhaps not always duplicate and all public functions into an interface. How about a generic type that can make a reference counted object out of any normal class? With the constructor you can create the instance. We return an interface instance. The only thing I have to do when using it, is to put the keyword instance in between. What is the implementation for this? We have an auto-ref interface with an instance t. A class with the class restriction. We pass the corresponding object. This is stored in the local variable. The moment this object goes out of scope, the instance is also released. Let's move on to trick 7. This time we have a worker class. The worker class has a value. In the calc value method, a super difficult and lengthy calculation is performed. For this reason, we want to run the whole thing in a thread. So button 7. First, let's disable the button so that the user doesn't click twice. Then, of course, we want to run the whole thing in one thread. In the thread we define ourselves a local variable. Again about our auto-ref. Then we create the corresponding instance. And call the calculation routine via the interface. Of course, we still need to unlock the button now. But actually I want to release the button only when the worker is destroyed and not when the calculation is finished. So let's do it a little differently. We give our auto-ref a procedure that should be called when the object is released. For this we have introduced an optional parameter onDestroy. And onDestroy is called just before the object is released so we can pass the instance again. In this case, to read the values. The whole thing looks like this. As requested. For trick 8, what if I don't always want a 42? So I take my normal class's instance. So let's just set the value to 43. Red dot. And compiling this is also not possible. The left side cannot be assigned. Why not? Bar has only one getter that copies the record. Of course, I could define a setter now. But unfortunately that does not work either. That means I have to take a local variable. Assign the value of this local variable and return it after the change. It would look like this. That works. However, this also means that the complete record must be copied twice. You can do better than that. So let's take another look at our class. How about giving argfoo a p-foo? And yes, you can write that before the record. Therefore we can do without the setter. And create a new property. We can do without this one as well. Now we can just use the new property and assign the value easily. And there we have our 43. Actually this is a pointer and we should write this like this, but there is the simplified notation. Trick 9. I click on the button. And I get finished in the log the text button 9 click. How does it work? There is the delegate onDestroy here that has this procedure that outputs the text. Preferably only after the sleep call. But why does it work? The delegate onDestroy class is created using the construct class function and returns an interface. And when this class is destroyed, the procedure is called just before the destruction. This is actually an invisible variable of type interface. I call this a ghost interface because this interface is captured here by the button click procedure. The interface goes out of scope when the routine is terminated and the procedure is called. Okay, trick 10. In trick 10 I want to fill a dictionary in a thread. For access within a thread to the dictionary, of course I need to lock them for foreign access. The normal way is to use the spin lock T monitor enter and exit, secured with a try finally. This allows you to call this procedure from the outside from any number of threads. This variant is much nicer to read. Why does it work like that? This is again a ghost interface. Let's take a look at the implementation. We have this class which again returns an interface. Who is destroying the instance? First the lock is executed and the ghost interface is simply passed up one level using the delegate onDestroy we just learned. What can I do with it? Well, for example, something like this. I create the dictionary, and then create elements for the dictionary using 3 threads. It should be clear to everyone that this cannot work. I have a local variable and have 3 threads running. I have no idea when they will finish and when I can release my local variable. But that brings us to trick 11, and here we combine a few things. So how do we rebuild that? First, we use the interface variant for the dictionary. Create this, and before the dictionary is released, we output again all values into the memo field. Then we create a filler. We'll see what the filler looks like in a moment. The filler is again generated via an auto-ref. The filler gets the interface of the dictionary as if the filler holds a reference of the dictionary, even if the procedure is long out of scope. So we create 3 fillers and call these instance with run and pass the own interface. And that's actually already trick 11 and 12. Now let's look at the filler implementation. The filler gets the instance from the thread dictionary, an instance on itself and a procedure that it calls to fill the whole thing. The instance and the procedure is passed in the constructor. When I call run, I pass my own instance to myself, and here comes the trick. I save this to myself, then call the procedure in a thread, and when this procedure is processed, I practically kill myself. The moment the filler is released, instance from the dictionary goes out of scope, and if there is no instance left from dictionary thread, not to forget the instance in the button click routine, then the dictionary is also released. And before, of course, still output. The whole thing then looks like this. First, the whole values are generated and then the output is fired. Okay, trick 12. Let's play a bit more with interfaces. Fluent creation. This means that you use an interface that only has functions that return its own interface. This then works as follows. I just modified a bit an older JSON implementation that I built for an older Delphi version. I have the possibility to pack different values into a JSON string, and the implementation is as follows. When the start method is called, the JSON string is initialized by hand. And a target procedure, that is for a RESTful web service, is passed with it. And very important, every function, like for example here in the add string, always returns self as result first, so that the instance can be passed on to the next procedure. We'll get to the skip in a moment. It will look like this. Memo lines add make JSON construct, start to JSON. And so this mini JSON string is created. And now if I want to add other values, for example add string name as Frank. And I can say add integer age is 55. And already I have assembled my JSON string here. I like to format it like this, because then it can be read optimally. Trick 13. The skip function. In this loop I have now simply installed a skip. The first parameter is the condition, so if I is greater than 1, then I-1 calls are not executed. It will look like this. At 1 all values are still written. If I is equal to 2, a call is omitted and the integer field is not inserted. If I is equal to 3, the Boolean field is also not inserted. Each of these calls checks the skip condition. And in the skip function the internal counter is checked if it is 0. If yes, this is decremented and the function returns false, which means that the string is not added. And in the condition, we check the condition and set the skip counter accordingly. Of course, you don't always want to have the interface definition and the implementation in the same unit. So we create a new unit and call it Trick 12 interface. And then we copy the interface part to the other unit. In this unit, of course, we need to use the interface unit. If we now want to use the class just shown with the interface, we must of course insert the interface unit here. Of course, this is something you don't always want to do. Always inserting two units just because you want to use an object. Why did we make the separation then? With this you can use the interface in another place without linking the implementation. But there is a trick for this. Namely, we can simply write here in the unit that implements the interface. Our IMakeJSON is located in the unit Trick 12 interface IMakeJSON. And by redirecting it, I now don't need to list the unit here in the main program. And it still compiles. Let's move on to Trick 15 for a different topic. The button opens a new window, and when I click on the message button, a message appears in the memo of the other window. How does it work? We have subscribed in the onCreate of this window to our own message type via the message manager, and when someone sends a message to this message type, this procedure is called, which then outputs the text to our memo. And when we close the window, we unsubscribe again. And the other window does nothing but click on the button to create the message and send it. Very simple. Trick 16, same button. The message arrives the same way, but I get the message in my memo about how many lines are in the memo. Of course, I don't just count that. But no, we just generate a few more lines and lo and behold that works too. But how? I have defined a new message type with the name log message info. Since we are not only transporting a string, but also an additional procedure. That means, I send a procedure with this message. The button then does the following. It creates this message. It creates not a string, but our new message type. This is created with a string and a procedure. And when the procedure is called, I output the information to the local memo. And in the main program there is a new subscribe. When the message arrives here, the text is output to its own memo and then the procedure is called with the current number of lines. Let's move on to trick 17. Of course, again, interface based. Here I simply define this message handle as IInterface. And make the subscribe on this IInterface over the FDK message handler. I just specify here that I want to have a string and a procedure that receives this string. So no more hardcasts with as XY, because that's all totally unhandy. I also don't need a local integer for the unsubscribe anymore, the message handler takes care of that via the interface. The subscribing is much more practical, and if we look at the sending, I only send out the message type with a string. And that works, too. Trick 18. The homework question number 1. A small calculator. Here with a slightly different approach. Our class has a dictionary. Yes, who did not know yet, you can define local types in a class. This has the advantage, if you want to create the dictionary, you don't need to repeat all parameters. The dictionary has a string and can store a function that takes 2 integers and returns an integer value. There is also a learning function. The learn function adds the function by lowercase name. And there is the calc function, which searches the name in the dictionary and returns the function and calls it with the parameters. Let's take a look at how this works. Trick 18 calculator. And like any good calculator, it always returns 42. And the call then looks like this. I create a local instance from the calculator. And for those who haven't seen it yet, I don't use the classic constructor here, especially when I don't need parameters for the class, but the methods after construction and before destruction. To create the dictionary, respectively to release it. With the learning function I can say, if I want to add then use this function. For subtracting use this and the same for multiplication and division. 21 plus 21 equals 42. 43 to 1 equals 42. 7 times 6 equals 42. And 518,490 divided by 12,345 is also 42. Let's test this. A and B result is 42. Of course, it is quite unwieldy if I always have to call the learning methods before a calculation in order to then be able to call the actual operations. Of course, it would be nice if I could store this in the program once and then this information would always be available. Of course, you could now define this class as Singleton. But Singleton are now considered anti-pattern. Allegedly because of the unit test capability. But this class is unit capable, as it is a normal class. How do I make it a singleton now? First, I need a local class variable. so that the instance remains in memory. For now, however, I'll take an intermediate step. There is a function current and a function setCurrent. You noticed it again, of course. I created the instance here and never released it. So that would be a memory leak. Calculate setCurrent is equal to calculator create. I know that looks weird, but we'll change that in a moment. The local variable can then be omitted, of course. I can now call the learning function via the local instance. With the button 18 I can now learn the functionalities. With button 19 I call the whole thing. We still have to add one supplement now. Because who will release the local instance? For this we need the class destructor. That looks good for a start. But what if I don't press button 18 but try to calculate directly? Well then no one initialize the thing, but then that's our next trick. That means in our function current, we can delete the setter already. Here we test whether the instance has already been created, or was not created. And in this case we do the so-called lazy init. This means, here the calculator has already been created and can be used immediately. If I don't execute the learning function before, I get the corresponding exception that the functionality is not known. So do I want to make this effort every time for every class? Actually not. And that leads us to the next trick. Apart from the fact that this implementation is not thread safe, I have now removed everything that we do not need anymore. And rename the calculator to calculator base. The implementation I want to use program-wide is the class tCalculator of type create on first init of type tCalculator base, and with that we are done. And how does this implementation work? I just click on the button, and I get my result. In the button itself tfdkcalc is default. I call it default not current. So I can simply calculate here without having pressed the other button. Of course I have already called the learning functions in the initialization part of the unit. Thus the dictionary is already filled at the start. With first call, the object is already created. And at the end of the program again released. And all the fun works with this one-liner. The unit test capability is preserved because our base class is still a normal class. My implementation is 100% thread safe and can do a bit more.
There's a fire burning out on the street. I can't bear this heat. You claim it was my fault.